Good afternoon. This is Nick Mosley, UTCID KHY 111. This is the fourth midterm problem here, notated as problem number 6. Prompt for it is to implement a function that meets the specifications below, which I've thrown here in my code. So def max underscore val with the T as a subset here. So the T, a tuple or list, um, each element of T is either an integer, a tuple, or a list. No tuple or list is empty, so you can see in here they're all filled, and then we have the lone integers up front here. Excuse me. And then so essentially we are just traversing this excuse me, this prompt given here, these are the testers given. And so we're traversing the list, making sure that we can find the largest number in this range here. So what I did here, oh, and so returns the maximum int in T or recursively in an element of T. So yeah, essentially what we did here, set a variable of max number, so max num equals 0, set it to 0, obviously. And then we are just going to traverse the list. So for each item, integer, nt in the list t, so max value, so which we were set here. Then I set this one just to kind of show that it's traversing the list. I'm not quite sure what that actually proves here. Um, looking at it again, but I just thought I'd put one with just a single solitary number, which was 1. But anyways, essentially what I did a try and accept block just so it wouldn't throw any syntax errors. Essentially I was just doing the for and then if and then as excuse me else if statement or elif of course there with these prompts in it, and it wouldn't traverse it with the different data sets in there. So I just did the try and accept block. So, it just kind of bypass those errors and traverse the main list. It seemed like the cleanest, easiest code there. But essentially, yeah, so it is just going to go through for the integers and, excuse me, and the function here. And then so if this number is greater than the max number, which is initialized at 0, max number is going to equal I. So like it would go through this list, it would set it to 5 there. If it throws an exception, which it would here, going from this to that, um, it will take a look at this and essentially do the exact same evaluation. So if max value of I, which in this case would be 1, is greater than within the max number, which will be set to 5, then it equals that, which in this case it wouldn't, since 5 is of course greater than 1, and it's going to return the max number. And so it'll traverse each one of these numbers here, and so these are of course duplicates, and 5 will be the highest, so that's what we'll see here. And then so yeah, of course you can see the output, excuse me, is going to be that 5 here. And then so on this we would have, oops, um, this list here. We would have 5, and we'd take a look at 5. It would keep going back through this. So for each I and T, so it would go through each number and data set here. They're going to try and accept blocks here, or excuse me, accept and run through. So on here, if it's programmed correctly, it won't stop at 5 and just throw back out 5. It's going to actually traverse the list. We might have just gotten lucky on that first one, but we'll see. Hopefully it'll read this 9 here, and so we'll run this, and yeah, throw on the 9. And so yeah, what we'll do here, excuse me, we'll run this again, and essentially, so if the code is functionally correct, fundamentally correct, however you want to verbalize that, this 1 would be the one, the integer would be the one that's showing, since it wouldn't be replaced, since it's greater. Like if I put if greater than or equal then, it would be replaced by each subsequent one, but since it's if I is greater than, it would never really be like quote unquote thrown out. So, but anyways, we'll just run it just because it's here. And yeah, so showing the one, and if this is properly set up and what I'm thinking the logic on here is, it would be that one as the max value here. And yeah, that is the fourth problem, and we'll move into the fifth one. Have a good day.